Welcome to today's session. So we've got two talks lined up today. So one from Nitesh, who's going to talk about the Docker containers that he's been working on and hopefully sort of why they're changing and the plans for how we might want to use them in the future. And then Robert is going to talk about some surprisingly tricky issues with finding out exactly why a certain package has been loaded into your global environment and tracking down the kind of dependency tree and things. So without further ado, Nitesh.
Right, so I'm going to share my screen. All right, so I'm going to be talking about why the images, the Bioconductor Docker images have changed in the last couple of months. Firstly, let's just get into why the changes happened. So the new images are in the same spirit of the Bioconductor full image, which we had previously in the sense that they have all the system dependencies. They're called Bioconductor Docker, as you can see in the name. So Bioconductor is the organization name / Bioconductor Docker, and then you have tags, devel or release 310, and you can pull them from Docker Hub with some simple commands such as this. Docker pull Bioconductor, Bioconductor Docker devel or release 310. So I just want to say that we've deprecated the previous images, and we've sent out a few emails regarding that on the BioC devel mailing list. Basically, everything which was previously done has been deprecated, and they're going through the deprecation cycle right now. So why do we have these new sets of images? There's multiple reasons. I'll just highlight a few of them. So first of all is the maintenance, which is what the Bioconductor core team does for them. So the chain of inheritance for these images was too complicated for easy maintenance. I want to say it's not impossible to maintain them, but we want to maintain them pretty easily without too much work. And this was becoming a problem because of the way the inheritance structure worked. So we inherited from the Rocker our studio images, and then we had this intermediate container called the devel, base 2, core 2, etc. And they weren't doing us any favors in keeping the inheritance chain simple and easy to maintain. That's one of the big reasons. And the other reason is it seemed like most people were using the Bioconductor full images instead of the devel core 2, the release core 2, or the base images, or any of the community contributed specialty images, I guess, like the cytometry, metabolomics, so on and so forth. People wanted to install their specific set of packages, and they were just using Bioconductor full, so there was really no reason to keep the other images around. And we also wanted to keep the size pretty manageable. So the current Bioconductor Docker image is fairly reasonably sized and still includes all the system dependencies. And we also implemented a ton of best practices in the way the Dockerfile was written. So we followed best practices from Docker, and we also have a versioning system for the Dockerfile. And for any community contributions, we've implemented a deprecation cycle and basically a convention which is similar to how the packages work. And I personally think that the naming convention is more reasonable too. So Bioconductor Docker is the only image shipped by Bioconductor at this point. So there's nothing to confuse people with a number in the version name, or what is the base image, what is the core image, so on and so forth. If you guys have any questions, please ask. So I just wanted to touch on the reproducibility of the Dockerfile. So the Dockerfile, we've introduced these labels inside of them, which are very closely mimicking the description file of a package. We have something called the version number in this. So the version number represents the Bioconductor version. So this is for the devel Docker image. So it says 311, and then in the Z, the .z, I guess, where it says 311.1, that represents the version of the Dockerfile itself. So if people need to like use a specific version, okay, so this is, I need to change that screenshot because it says 311.0 up top and then 311.1 in the version number, but I'll change that. But it gives you a way to like know which image you're using if you use the command docker inspect. And we also have a place where the maintainer of the image can be contacted. So contact them at like maintainer@bioconductor.org. So this same labeling mechanism needs to be used by people who want to contribute Docker images to us from now on. And it also has like a description which is describing like what the Docker image does. There's also a license which shows like what open source license it's under. So in a whole, I think these Docker images from now and into the future will be more Bioconductor-esque, if that's a word. And we have also implemented this contribution mechanism for Docker images, which is very familiar to most maintainers and developers in Bioconductor. So images are very similar to packages now, and we'd like to think of them as being very similar. And you can contribute images just like you would a package. You go through the contribution page, you submit your image, it goes through a review process by the team, it follows some best practices, and then it gets accepted and put into the Bioconductor organization. And there's an extensive like document on how to contribute, which you can take a look at if you're interested in contributing any images. We've also added the devel build variables to this Docker image. So we've taken some build variables which are on the Linux nightly builder and put them into the Bioconductor Docker image, only the devel image, mind you, so that it mimics the Linux nightly builder a little closer than it did before. And it's easy for maintainers to reproduce bugs. If they see something on the build system which is failing and they want to reproduce it, they can use the Bioconductor Docker devel image and try and reproduce it within their local machine, on the Docker image though. So that's one way developers will find this very useful. And Martin recently debugged this SAM tools issue using the Docker image, and I'll let him talk about that a little bit.
Sure. Can you open the link for it?
Yes, absolutely.
So it's just kind of...
One second.
It's just a kind of a tricky bug that was reported in our SAM tools. It was reported by Janet Young, who is at the Fred Hutch. And she, if you have a hard bug, you want Janet to be the one who has it, who's reporting it. She's excellent. It was, she observed a seg fault when this BAM file was being parsed. And of course, the BAM file is, millions of records, and somewhere in there, there's a bad record. And it's not easy to sort of share it. But she worked diligently to identify a minimal example, like just a few records from the BAM file. And she also worked to show that she could reproduce it at least sometimes with that minimal BAM file on Linux and on Mac, more reliably on Linux. The deal with memory bugs like this is that it depends on whether you see an effect depends on just how the memory is laid out on your computer, and on Macs apparently whatever the issue was, the sort of accessing the wrong part of memory, didn't have big consequences reliably, whereas on Linux it did by the time Janet got through with it. And that's great, except that I'm not on Linux. I have a Mac, but then I knew that we had these Docker images, so I fired up Docker and installed the devel version of SAM tools and used the example that Janet and Hervé had come up with, and then it reliably site faulted on Linux. And I also had the access to the Linux development tools like GDB for source level debugging, and also Valgrind, which is used to detect memory access errors that are more easily accessible on, at least for me anyway, on a Linux platform than on my Mac. So actually, the Docker image was really helpful in providing a standardized environment where I could figure out what the underlying issue was. That's my little story.
Yeah, that's pretty awesome. Like, so I wouldn't have known how to reproduce this had it not been for this extensive documentation. I tried a little bit before this presentation. I didn't get too far with it, but maybe next time. Where is my presentation? So this is a little. All right, I'll just continue with the rest of it. So I just want to add that if there are some bugs we might not be able to, like, just note that the devel Docker image still has a long way to go before it emulates the build system, the Linux build system at least, perfectly. There's a few complications which are in that way. Like, it's not an extensive list, but it touches on a few of them. So the way the packages are installed on the Linux build machine is it pulls from the Git repository for Bioconductor directly, and it doesn't just do like a BioC manager install. So if you wanted to mimic that part of it, you could just do something like a git install using DevTools. I forget the exact command, but it's like install git or something like that in DevTools. So you could mimic that. And there's no vignette builder within this image. So you'd have to install LaTeX and some of the system dependencies LaTeX needs. So you can mimic this as well if you go to the Docker page on the website and look at a couple of examples I gave out on how to extend this image. But it adds like almost a gigabyte or two of size to the Docker image. So we're shipping a smaller image than shipping something with LaTeX installed on it. And it's important the way you host your libraries in the way the volume mounts work for this to work. So that's a little tricky and like needs to be done the right way so that the image is working similar to the build system. And these are some links for folks to look at and read through. And if you want to contribute to Bioconductor, like Docker images to Bioconductor, like we've put together like a pretty good document which kind of lists it out. And that is it. Questions, comments?
Nitesh, one question.
Go ahead.
Yeah. The images that people may contribute, what kind of images is in principle expected to be? Like images with installation of a number of packages or a workflow, or what kind of?
So if it's just like, so the base idea is you extend our image in some way, But if it's just installing more packages on top of it, I'm not entirely sure how useful that would be. But if it runs a workflow, like a specific workflow,
Okay.
and it installs packages and a workflow package and some additional dependencies on top of that, on top of our image, then that might be useful to run a specific workflow, and people can use the RStudio interface, so on.
Okay, that makes sense. Like workflow for differential expression, and then you have the image with everything installed, and you can right away use everything. Okay.
Right.
And the other question was, I mean, I'm not expert at all in this, but I heard that with Docker, you may have some issues related to security. And some people use something called singularity that seems to be more secure or less flexible. And what do you think about this if you're familiar with these two technologies?
Right. So I'll just share my screen once again. Yes. So I just want to say that we also have Singularity images available. The same Docker images are hosted on Singularity Hub, and they can be used as Singularity images as well. So if you are specifically concerned about some of the security issues with Docker, you can use these images as Singularity images, like using the Singularity runtime. Does that answer your question?
Yeah. Perfect. I didn't know it.
Cool.
Yeah, I'll just add that we're not allowed to run Docker on our cluster environment because it's basically super easy to elevate yourself to root, or at least to mount certain things and then have root access to them. But we are allowed to run Singularity, and I've been using the old Docker images in Singularity, and they work completely seamlessly. Singularity will actually take the link to Docker Hub and then just do it in the background for you as well. And so that works really rather smoothly. I'm very impressed with it. So I can use Docker on my local machine and Singularity on the cluster, and everything just kind of works in the same way.
Yeah, that was exactly why I asked, because in our environment also our sysadmins say, no, don't use Docker, and we should use Singularity.
That's great. Yeah.
So I just want to say I totally agree with the naming change. I was always confused by Bioconductor full because the name made me assume it had everything from Bioconductor in it, and it's actually the complete opposite, right? It doesn't have any Bioconductor packages necessarily. Right. It just has all the system dependencies. So I always found that a really confusing naming convention, whereas this seems slightly more clear to me. When you use images, how do you mount the library of packages you actually want to use? So I guess something I've been doing is trying to build the book, the single cell analysis book thing. And essentially what I do is run the container and then mount a particular folder that's on my local hard disk that is my library. But that kind of defeats the whole point of it being self-contained and reproducible by somebody else, because that's on my local machine. And if I share the container with them, they don't get the same library, right? They'll have whatever's on their machine. So I just wondered if you had any kind of, do you install everything, like build a new image with it all kind of compiled in and then use that and don't install new packages? Or how does that, do you have any recommendations basically?
I guess if your goal is to share stuff with people, extending the image with the packages and data sets is the way to go. And you share that image with a much bigger size. But this one, at least, the goal is to share it with, I guess, the goal is to distribute this image as the base image you can work with. So I would say extend the image with the packages, unless people have better solutions. Or you can possibly share your library, I guess. So when you compile your libraries and store them in some folder, So they're already pre-compiled on this Docker image. So essentially, these binaries just need to go and get attached to that Docker image. So if you have a way to share that folder, it'd be even quicker for your collaborators, right? Like all you have to do is like mount those compiled libraries to that Docker image, and it just works.
Yeah, I guess it depends what you're trying to do with the image. So I guess if what I'm trying to do is share something with somebody in my institute, that's fine. If I want to give the image to somebody else to run the same workflow, so in this case, I want to say you can use this Docker image and you'll be able to run everything in the single cell analysis book, right? Like if that's my aim at the end, is to say you don't need to install all of this, just get the Docker image and run it, then I need to build everything in and say this is the version at this moment in time that works, which I guess is slightly different from helping maintainers like build new bits and check it works with the current versions of the package. It's something I haven't resolved, and maybe your versioning issue kind of thing is actually something that I want to kind of look into, where I would have this works right now, but if you're right at the bleeding edge and you're adding a new chapter, then you should be using kind of your own local library and that sort of thing. But yeah, it doesn't feel like it goes against the reproducibility thing to have this like mounted version of the libraries that work now, but I can't share them with anybody else. And I haven't really resolved that to myself yet.
I was going to say, yeah, I guess when we were talking about the size of packages, right? And when packages get really large, they're really onerous to download and move around, and many people aren't interested in it. So that's in keeping or having, when they encounter a package that's that size, it's intimidating. I think the same is true with these Docker images, that there's some value in having a compact Docker image that's easy to install and use. There's also like this separation of the software to do the computing and the data that the software operates on. And in some ways, the packages are like data. So it's kind of like the experiment hub, annotation hub idea, where you have this superficial package that stands in front of this big data, and then you access data resources from Annotation Hub. It's not like you download all of Annotation Hub. You just get the specific resources that you're interested in. So I think it's actually kind of fun, the idea that you could have like these, because you have this consistent binary architecture on the Docker container, you can actually have these built binary packages and say, maintain a repository of just like Annotation Hub. These are the packages you need for this reproducible analysis. So go out and install these archive binary versions, mounting them separately, and then go on your way. And maybe it's not such a bad solution in the long run.
I guess that's what people like Debian are doing, right? Like if you can go to the central Debian repository and download the pre-built package for that version of Debian or Ubuntu or whatever, right? And it might not be the bleeding edge, it might not be what was released last week, but it is quicker to install, and I guess you are in some sense guaranteed that it's going to work.
Yeah.
I guess I would also, I appreciate the opposite end of the spectrum to what Martin talked about, where you are using this to replicate the build system to find a problem. It also works nicely where if you can't get something to run on your local machine or on your local cluster or whatever, you can download the Docker image and run a package there because you know that it should work, right? If it's as close as possible to the build system and the package builds successfully and runs successfully, then you can use that to circumnavigate kind of weird dependency issues and that kind of thing, which I guess is what I've been trying to do with the building this book, is that there's so many dependencies and it takes a long time to run, but everybody's computer architecture is different. And so including our kind of native cluster. But by using the Docker images, everything seems to actually work relatively smoothly. Do you have any idea how many people might want to update, or how many updates you might expect per Bioconductor release cycle? So there's like a third point in the version number.
I mean, they should be pretty stable for the most part. There shouldn't be more than like one or two, if that. If something gets broken in the image, or like there's a update of the minor version or something like that within the R version. But otherwise, I don't really see why we would need to change versions too many times, both within release and develop.
I guess you might want to keep it in track with the most recent version of R. I hadn't really thought about R and R Studio kind of updating within a 6-month window, but they will do, won't they?
Yeah.
So in 1 6-month cycle, it doesn't matter because we're using the stable version of R and there's not much updates. It would be like this cycle where it's our devel that might need to add in a couple extra. But.
Right. So we don't foresee too many changes, I guess. I guess that's the compact answer to the question.
Yeah, again, I hadn't thought about this. So the version of R that's in the current image is the version that developers should be using to develop new packages. Is that right? So yeah, for 6 months of the year, it's R devel, and for 6 months, it's the stable version.
Right. Yes. So if you're using the Docker image, you don't have to keep track of that anymore. All you have to do is pull the image before you use it and keep using it like you did before. That's it. Just go along with the versions of latest and devel, and that's all you need to worry about.
Cool. And yeah, can I just ask what the very last, well, penultimate slide, you have the important to share the host site library. What does that mean?
Right. So if you're, where was that?
On the complications slide.
Right.
I should
so
just say that.
I guess what I meant by that was, what did I mean by that? So you need to share it within the right location. So we have this special path in the Bioconductor Docker image, user local lib r host site library, and that needs to be mounted to whatever location on your local machine which hosts your compiled binaries. Does that make sense?
Okay, so that's the place where I should be mounting my library. I guess
Right.
I'm just mounting it wherever seems convenient and then writing a .r profile that accesses my convenient place. But yeah, okay, so this is the sort of official place that I should be mounting it.
Yeah. So basically, we have it pre-built into the image to look at that path and add it to your search path within R as the first one. So it just looks at that by default if you share your library to the right location. But yeah, I think that's what I meant by that. Yeah.
Cool, thanks. So I guess if there's no more questions for Nitesh, does anybody have any? As a no, thanks very much, Nitesh. In which case, Robert, you're up.
Yeah, let's see. Let's share the screen. be seeing now slides. Is that correct?
That's happened.
Yeah.
Okay.
Yes, we can see.
Okay, excellent. So what I want to talk about, I think, can be summarized with this title, Quantifying and Lightening the Package Dependency Burden. And as you know, this originated a couple of weeks ago in a question I posted at the BioC devel mailing list. This came because in one of our servers, the genomic scores package, the package that I maintain, was breaking when it was installing due to a compiler problem with the matrix package, and I was surprised because I didn't expect that genomic score was depending on matrix. So I started looking just like where was this dependency, and it was not immediately clear because it was upstream, and that's why I thought there must be an easy way to see this. And well, actually, so the genomic scores package, because of few things that we were adding, now it raised the number of dependencies to 116 in the development version back then. And this is the session information. When I look at it, then I saw that the matrix package was there. And with many other packages, we also added recently this version of a Shiny app and so on. And then the question was how to get there. And well, after some exchange of emails with Martin, we came up with this first solution in which you use this repositories function from BioC manager, the available packages function, and then a function called package dependencies from the tools package, where I get these 116 dependencies, and then you can build a graph of these dependencies and a cyclic digraph, which is, for instance, here depicted on the right. And here you can see genomic scores depends on DT, DS genome, and airdraft layer, and through these three dependencies, you end up with matrix. Okay. There is because it's a graph, there is a function in the igraph package called all simple paths that gives you all the paths between two endpoints. And this is what I did, and you get these 5 paths from genomic scores to matrix. Then you can see why you get the dependency upstream. So there was some discussion about after this. As Martin suggests, it will be interesting to identify formal strategies for removing dependencies and measure the ease in which a package dependency can be removed from group dependencies. And then he mentioned also the itdepends package, and I didn't know at all about this. Other contributions to the discussion followed by Dean's Carey, where he posed two questions that are interesting to address. That I think one could interpret them from the developer side, which would be, how do I quantify and lighten the package dependency burden for a package that I'm developing? That's one side of the problem. Another side is the side from, I guess, the Bioconductor core team that has to maintain the entire Bioconductor ecosystem, which is, how do I identify packages that compromise and maybe also be compromised by the package dependency border, that can break the building chain, or the chain of building packages, right? And how can we do this in a systematic way? Then Sean Davis mentioned the BioC package tools, which is a package that was also described in a paper in the F1000 research journal, and currently has an error, doesn't build, but I look at it and has several functions to examine the Bioconductor build and dependencies and so on. regarding dependencies, it doesn't go beyond just looking what they are, building the graph of dependencies, showing this graph. I encountered a problem in which it wasn't getting the dependencies from CRAN, and well, it may need some adjustment on those issues. But what I found more interesting was this package itdepends from Jim Hester, who presented in the RStudio conference in 2019, 1 year ago. And here is the link to the video of his presentation. It's about 20 minutes long, and if you're interested in this issue, I really recommend to watch his talk, because I found it very enlightening. I think he raised more or less all the issues, or many issues that are relevant to packages dependencies, and which I would summarize in these bullet points here. So first of all, dependencies break. We all know that. Not all dependencies are equal. Some dependencies are more upstream. Some other dependencies may have very strict system-wide requirements, and so on. And then, depending on the users of your package, you may want to have more or fewer dependencies. So for developers, a package that is geared for developers, you want it to be lightweight and stable. A package for end users that analyze data, for instance, should be feature-rich to meet the needs from the users, and there maybe you have more dependencies, obviously. If you depend on widely used packages, that might be more reliable, because widely used packages are widely tested by the large user base. You may want to remove dependencies from your package. While, like in my case, you notice that there is a dependencies that has some problem installing, and actually you wonder why you have it. So in this sense, quantification of what Jim calls the dependency weight is critical to make this decision. So the package itdepends is meant to be a toolbox to make this type of decisions. These are his own words in the presentation. And he also, among the many things that he lays out in this subject, I'd like to highlight one of the metrics that I found interesting, which is the contrast between the number of functions exported from the dependency and the number of functions of each functions that you are actually importing in your package, provide a sense of how much the package dependency you are using. Okay? And with an example later of, I hope this becomes clear. So this package, itdepends, it lives in GitHub, it's not in CRAN. So you have to install it with install GitHub. It has several functions. The two that I like to highlight here is dep usage package that determines users of dependencies for the package, and dep weight, which calculates what he calls the package weight. I'm calling here the package dependency burden. The package is now for a year in GitHub, hasn't made the way to CRAN, hasn't been updated for a number of months. There is a number of issues that are open, so it doesn't seem to be actively developed. But I think it's a very interesting API for building on top of this package, building strategies for quantifying and lightening this dependency burden and the needs that we may have to answer the two questions that I posed at the beginning. So for instance, let's say that I call deep usage package with dynamic scores, and I do it I'm doing this in the release version of dynamic scores, because in the development I really fixed the dependency that I wanted to remove. And you get the result is something like this. It's this table where you have a column with the name of the package, and another column with the function that you're calling from that package. So the base, you call it the standard generic, and this, well, obviously the base calls are not that interesting. And here I have, so 1,353 rows in total. If we cross table the column of the package, then I see, for instance, how many calls I do to every of my dependencies. Okay, so obviously most of my calls are calls of dynamic scores to the base package, but that's That's it. And one thing that I noticed that I don't know why is the case still, I don't fully understand, is that in the namespace of the genomic scores of the release version, I'm importing these two things from biostrings, the match method and DNA basis. And the biostring doesn't show up at all here. So I don't know why this function is not catching that. So this is one part of the story, how much I'm using for my dependency. The other part is how much is exposing the dependency. One way to get it is with this function get namespace exports, which you get everything that is exported, and if you discard some stuff that starts with a dot, that I'm not sure what it is, but doesn't look like the stuff that I potentially can use, then I get 240 things that are exported, out of which I know I'm using these two here, okay? So this answers this question about how much I'm using from a dependency. The other part that I thought was interesting is biostrings has its own dependencies. What is the fraction from my dependency graph taken by the dependencies of biostrings? So how much it represents in the dependency part, right? And for this, I wrote a gist, so a script that is stored as a gist in my GitHub repo, GitHub account, and you can use it in this way. And I provide a few functions to explore this. One is called package dependency graph that builds this graph of dependencies. And if I do this for the genomic score package for biostrings, and then I look to the ratio between the intersection of the dependencies divided by the union, which is called the intersection union, it's the Jafar index, then you get that there is a dependency overlap, we may call it from 0.075. 0 would be totally disjoint graphs, 1 would be identical graphs, so 0.07 is a very tiny fraction. So this script actually has these three functions. The one I show you with the dependency graph, one called package dependency metrics that does what I just show you. It's encapsulated in this function. And then function calls to dependency is when I want to know what function calls to a package lead to a target dependency of interest. So for instance, well, this is what I just saw about the dependency here. If I call this package dependency metrics, it gives me a data frame where I have for every of my dependencies, of dependencies, in this case of genomic scores, the number of functions imported by the dependency. So I import one function by base, one from the genome, and so on. The number of functions exported by each of these dependencies. Then the usage, which is a fraction of these two quantities. Okay. And here this, and then the dependency overlap, which is this quantity I described. This data frame, this table is ordered by usage. So I have from pure usage to more usage. And then the idea is that you look to the dependency that you are using the least, but that has the largest overlap in the dependency graph, that represents the largest portion of the dependencies. And here a clear candidate is DS genome. I'm just using one function from DS genome, so it represents 1% of functionalities posed by DS genome, but it represents a fraction of 0.56 in my whole dependency burden, the dependency burden of genomic score. So it's a great candidate for being removed as dependency. This is what I did actually in the devel version. So this would be one way to.
Can I ask? I'm not understanding the dependency overlap. Does
yeah,
that? Yeah. Does that mean?
Sorry. Yeah, go ahead.
Like on the summary slide, that 0.36, does that mean that 36% of the dependencies in your package come from BS genome, or does it mean that your package and BS Genome share 36% of their dependencies? Or?
No, it cannot be interpreted in percentage. This is a degree of overlap. This is, I didn't have time to make a graph. With a graph, it's better understood. So you have two graphs, and in these two graphs, whenever two nodes are present, they have the same links. Okay. So in the end, you're just comparing memberships, and you want to know from the union of these two things, what is the intersection? So the intersection, how much intersection overlaps in the whole union. So if the intersection is equals the union, you're looking at the same thing. The two graphs are identical. So intersection equals union, then the two graphs are identical.
Okay.
If the two graphs are disjoint, there is an intersection, so they don't share any dependency, then this index is 0.
Right.
So it's the fraction that the intersection represents with respect to the union.
So then on your next summary, in the summary table on the next slide, doesn't that mean that although you're only using a small amount of BS Genome, you're actually not spending too much for it? Or like most of the dependencies, maybe that's too strong a word, but most of the dependencies are already present from elsewhere?
Of course, that's another. So to know how much of the BS genome here takes a large fraction of the dependencies of genomic scores. Now, to figure out what happens when you remove it, whether these dependencies are shared by other packages, that's more difficult to answer, and it's not captured by this metric. But obviously, if this dependency overlap could be a small number, this means that by removing BS genome, you won't be removing a lot of dependencies. The contrary may not be true, but that's why I say it's a good candidate. So you just try, remove it, and see what happens. Of course, looking at the graph, you can more easily answer this, because looking at the graph, you can see whether the dependencies of BS genome are also used by other packages of your dependency graph or not. This has to do with this idea of looking at the paths in the graph and so on. So there is more to this, of course, that could be investigated and exploited, this information. This is maybe scratching only at the surface of what you can do with this information. But for me, this was the way to identify matrix in original problem, and also BS genome. You may imagine about BS genome being an issue. And another function that then I developed this function calls to dependency. Then I say, okay, then BS genome is, I'm using just this one function call. And what is this function call? And then it tells me to call to something called reference genome. It is an accessor that I use to return the genome description object from a discourse object. And then I saw a way to so I was actually importing BS genome to import this as a generic, and actually what I did was to change the name of the generic, because this is mostly used internally in the package, not really exposed to the user. And then I could get rid of this dependency. And in fact, then with this, so removing the dependencies from matrix and BS genome, I went down from 116 dependencies to 72. This, I think, quite substantial reduction. Other way to call this function that I didn't have time to show it is that if you give the path to where your source code is, it uses another function from itdepends to show you the actual lines of code that have this. And this is part of the itdepends API. And well, that's it. The question here would be whether there is maybe additional interest in or other needs to extend this kind of functionality. Whether maybe it would be nice to have it available in the BioC package tools. Could imagine BioC package tools in principle also it's able to pull the information about the building system. So maybe for the core team, it could be interesting to cross this information of the building errors with this dependency burden. Is there any correlation between what packages break and what packages have a larger dependency burden quantified in some ways? And I don't know. For me as a developer, this was really lightening to see how to deal with the packet, with the dependency graph, and help me to identify this. So, and well, that's it. I don't know. Any questions?
Yeah, thanks very much. That's it's actually super interesting, right? It seems like such a trivial question, and actually, it's really not trivial at all to try and answer these questions. So, was it was biostrings, right? Like that you used two functions from, or that you imported two functions from, but weren't showing up at all in the stuff from itdepends. Did you look at your code? Like, are you genuinely using them in the code?
Yeah. These functions are used for genomic scores when you use it to query scores from allele frequencies. Then there is the possibility to query for the allele frequency from a. So in principle, it was assigned to retrieve only minor allele frequencies. But now you can also query for the allele frequency of the reference allele and the alternate allele. And this is done through arguments ref and out, to which you give nucleotides. And then it uses BioString to be able to accept DNA string set objects for DNA strings stored in that format and so on. And then it enforces these two DNA bases and the match function from biostrings. But in the end, biostring, the dependency, so it represents a little fraction of the dependency burden of genomic score, so it doesn't bother me too much.
I guess it bothers me that it doesn't show up in the itdepends list, right? Like, that's a little bit troubling. In that, do you trust all the other numbers if have an example that you definitively know it's missed, right? Like, something's not worked.
That's true. So in the fact that it depends doesn't seem to be lately updated and so on. Of course, it worries me a bit when so Sean said, you can pull requests in BioC package tools to add functionality, but if what I'm adding depends on this itdepends package, which actually breaks in the current devel some of the functions because it hasn't been updated, I guess. So maybe I guess one thing one would have to do is to approach Jim and say, well, can you sort of put the package on CRAN or something and then update it? And because it's really, I think it's a very nice API for developing then flexible solutions that you may need. I mean, these two functions that I implemented was what I was needing for my package, but I could imagine the BioC core team may have other ideas about what do they need. And, right, so, and then the BioC package tool will be a nice place to put all this. But if you going to use itdepends, then we should either get Jim to put it into CRAN or maybe then try to reproduce what the package itdepends does in BioC package code.
Effectively, we wouldn't need to depend on itdepends. Deal with the code.
Yeah. I don't know.
Reuse.
It's just that.
It was the wrong word. Reuse. But yeah, I mean, I guess I have in the past used GitHub-based tools I've depended upon them, assuming that because they're done by someone like Hadley or Jim or somebody who's in RStudio, that it's on the way, it will be in CRAN soon, and 18 months later, it's a dead project that they're not doing anything with. So I guess I would caution against relying on things that are currently in GitHub that have not made it to CRAN. But that was all done without a conversation or anything, right? I just assumed because of who it was that it would be fine.
Yeah.
Who is actually maintaining the BioC package tools?
Davis.
So I guess we should talk to Sean about whether, I mean, I guess you quoted the emails from him that he thought this was at least an interesting topic, even if he didn't have the time to contribute himself. Because I think this is quite cool. The ability to formalize what might happen if you remove one dependency, or to weigh up how important certain dependencies are, seems quite a powerful tool, if nothing else.
Yeah, and overall, so the big challenge is from the perspective of the Bioconductor core team. Can you build some sort of metric that captures at a higher level what packages are in danger of breaking, or or if you could even detect, so a CRAN packet breaks, can you anticipate what's going to happen, like an earthquake or something? So can you anticipate who is going to break miserably in the next few days? That could be especially useful when the release approaches. So anticipate this kind of stuff. And then, of course, one way to anticipate it is to see whether you can make more robust the packages. So we get these emails when, your package doesn't build anymore. Maybe it could be interesting to say, well, your package depends on all these has so many dependencies. It's a little bit fragile. Could you replace this? I don't know, in some automated way, of course. I mean, this is already happening, right? With the shield of the number of dependencies. I think it's already very good, very informative.
Okay. Usually when you...
Sorry, yeah, go ahead, Martin.
I was just going to say, when you click on those shields, they usually go somewhere, and it'd be fun to click on the dependency shield and get a little report from Robert's software that points out the the deficiencies of your package.
Or even a tree, the tree of looping back the dependency.
Yeah.
I'd like to think at some level that the more number of dependencies you have in a package, the more likely it is to break, but that's not necessarily true.
No, exactly. Actually, Jim says something on those lines, says, less is not more. I think he summarizes it like, if you depend on packages that are widely used and well maintained, then you're safe, right?
Right.
I think sometimes the question is, we import functionality because it's very quick. We say, I just need this, and we are not aware maybe how much are we importing through that dependency.
I mean, I think we're actively encouraged to not reinvent the wheel, right? Like, it's part of the Bioconductor ethos is that we should reuse the kind of environment and the objects and classes that have been defined and that kind of thing. And maybe sometimes we take it too far to the extreme where we want to import some massive package that has one tiny little function that we reuse. And I've never thought about that. I'm always on the opinion that we just shouldn't reinvent things and we should just use stuff. But yeah, the dependency trees get huge very quickly, I guess, at the moment.
There is one issue I didn't also have time to prepare to talk about, but I think it's also very relevant. I remember I was always struck when I was using Lima that install Lima, and then I would use this function do correlation, and the function would ask me to install another package, the statmod package. And I thought, but I installed Lima, why is this asking me to install something else? And the explanation, because I posed that question to the devel a time ago, was that, well, this function is not so often used, so the package doesn't put it as a dependency, and it just politely asks you to install it when you need it. And I thought, actually, it makes a lot of sense for functionality that is not so, that you do not expect that many users use on your package, that you do not, and it has a lot of dependency or large dependency, that you don't put it right away as in part of your installation, the dependency to the importing, and then you ask the user to install it when the user is going to use it. And I think a very good example for this are Shiny apps. Because, for instance, now we added this Shiny app to the dynamic scores. I do not expect many users to use it, right? But by putting that there, it's going to increase a lot the dependency burden of dynamic scores. So what I did by now was to follow this strategy from Lima with the statmod package. But I'm actually not completely sure whether I'm doing it right because I'm loading the namespace dynamically. And well, actually, I wanted to put a question about this in the BioC devel because I tried to load the namespace from Shiny into the namespace of the package, but I couldn't because there was some locking issue. And I discovered that I can just put the stuff on the base package somehow. It looks to me a little bit not entirely correct, but it works. And I'll post a question about this. But so the idea of dynamically importing functionality for features that are not so often used, it's a way also to lightening the dependency burden. And more and more packages have Shiny apps, and that could be an issue to consider those packages.
Cool. In which case, if there's no more comments, and I think this is really interesting, it's definitely something we should kind of follow up, even if it's a bit more offline kind of thing. But yeah, if there's no more questions, thanks very much to both guys for speaking today. I've really enjoyed it. Hopefully other people have, and see people next month.
Bye.
Thanks.
Bye. Thanks. Bye.